Hi everyone, and welcome to this recap class of trigonometry. So without wasting too much time, let's take a look at this right-angled triangle we have here. It's the second diagram. Okay, so if they were to give us an angle, we can name it x, alright? Now before we get into that, the side that is opposite the right angle, so remember your right angle is this, okay? The side opposite to that is also the longest side in a right angle triangle, and it's also called the hypotenuse. Okay? Now, if we were given another triangle, x, the side that is opposite to the angle, which is this one here, is called the opposite side, and the other side that the angle rests on is called the adjacent side. So in trigonometry, we deal with mainly triangles. So there are 4 scenarios of different triangles using different information that they will give you. And you have to use different formulae, different rules to find them all. Okay, so we have 4 main types of questions. You may be given 2 sides and 1 angle in between those sides, and you'll have to use something called the Sine Rule. You may be given 2 angles and 1 side instead, and you'll also have to use the Sine Rule. Another option is 3 sides and no angle. Here you will have to use the Cosine Rule. And then finally, you can be given right angles to use. Okay? So the right angles are the simplest ones. So let's get into that one first and get it out of the way. So here we have a right angle, and we are given, let me erase this number over here. Right, we are given 2 sides, right, with and we need to find the third side. So for a right angle triangle only, we can use the famous Pythagoras Theorem. Okay, now if we were to label our sides A, B, and C, with C being the hypotenuse, as you can see, and A or B being any of the other 2 sides, Pythagoras Theorem states that c squared, also the hypotenuse squared, is equal to a squared plus b squared. Okay, now in our diagram we label x as the b. Okay, so if we want to find b, we first need to make b the subject of the formula. Okay, and you do this by moving everything that is on the same side of b to the other side and leaving b alone. Okay, so what I did was I moved a squared to the opposite side. Alright, so this becomes now b squared is equal to c squared minus a squared. Remember, when you're moving something to the other side, we change the sign. Okay, and now we could go ahead and substitute the values that we have. So c is 5, so 5 squared is 25, and a is 3, so 3 squared is 9. Remember, we are minusing a. Alright, so then x squared is 25 minus 9, which is 16. And to find x, we simply take the square root of the both sides to get 4. Okay, so therefore x is equal to 4. Very simple. Let's take another example. In this example, we have to we actually need to find x over here, right? So x is on the bottom there. We label them a, b, c. So this is me just showing you that it does not matter which of the other 2 sides you label a and b. Alright, so this is almost the same question with very similar numbers. We just need to label the hypotenuse as c and the other 2 sides either a or b, and it will work out just fine. Okay, you can look at this working yourself. You could pause the video and take a look at the working. Alright, this is the easier version of Pythagoras Theorem, where the side that you need to find is actually the hypotenuse. So in the original Pythagoras Theorem, c is already the subject of the formula, so there's no rearranging that needs to be done. Okay, so you can just substitute everything as normal and you will find c without doing any kind of complicated maths whatsoever. Alright, so let's take a look at what happens when we are given an angle, or if we have to find an angle in a right angle triangle. Okay, so again, let's take a look at this angle x over here in this shape. So we can identify the names of each side of the triangle. Remember, the side that is opposite the right angle is called the hypotenuse always. It will never be anything different. Now they give us x as that one in the bottom corner over there, right? That's this one here. So the side that is resting, that the x is resting on, is called the adjacent, and the side that is opposite to x, which is this one, is called the opposite angle. Okay, and this is how we get these three different types of formulae: the sine, cos, and tan. So sine is short for sine, cos is short for cosine, tan is short for tangent. So each of these has their own formula. So the sine of the angle, you just need to put in whatever the angle is in front of sine, is equal to the opposite side over the hypotenuse. Okay, so if by chance the opposite was 5 cm and the hypotenuse was 10, it would have been 0.5, right? That's all you have to do. Alright, the cosine, you take the adjacent and you put it over the hypotenuse. And finally, in the tangent, you take the opposite and you put it over the adjacent. So let's take a look at some examples as to how we can use this. So in this first example, we need to identify what information was given to us first before they even ask us anything. So let's take a look. In this example, they have given us an angle, 40 degrees. They gave us the hypotenuse, right? That's the one that is opposite the right angle. They told us it is 8.2. And they want us to find x, which is the adjacent side to the angle. They did not give us anything to do with opposite, right? So as a result, our formula needs to include the information that they gave to us, right? So they gave us the hypotenuse and they gave us the adjacent. So if we take a look at our formula on top over here, we need to use the cosine rule because the cosine has the adjacent and the hypotenuse. So we can use that formula and start substituting everything into there. So the x, they give us 40 degrees. So cos 40 is equal to x, which is the adjacent we are trying to find, over 8.2, which is the hypotenuse. Right? So we need to make x the subject of the formula. So all we need to do is multiply both sides by 8.2. We get 8.2 cos 40 is equal to x. We can simply put that in our calculator and we will get x to be 6.28 centimeters. Very simple. Let's try another one. In this example, they have given us an angle. They give us the opposite side to the angle, as you can clearly see, 6.3. And they want us to find the hypotenuse, the upright, it's opposite the right angle. So let's take a look at which of our formulae could work. We have the angle, we have the opposite, and we need to find the hypotenuse. So the only one that works with that is your sine, right? You have your opposite and you need to find your hypotenuse. So now let's substitute that into our working. So sine 24, that's the degrees, is equal to 6.3, which is the opposite, and x is your hypotenuse. So therefore we need to go and make x the subject of the formula. All we have to do, multiply both sides by x. So you get x sine 24 is equal to 63. Remember, when you multiply both sides by x, on this side the x's cancel out. So that's how we end up with 6.3. And obviously you need to multiply the left side by x as well, right? Just to remind you guys. Okay, and now we need to remove the sine 24 from the x side because we need x alone. Alright, so we need to divide by sine 24 on both sides. So by doing this, we get x is equal to 6.3 divided by sine 24. Again, all you have to do, you put this into your calculator and you are going to end up with 15.49 centimeters, and that will be your hypotenuse. Alright, now let's take a look at this one. In this one, we are given the angle. We have the adjacent side to the angle, that's the one the angle is resting on, and we have to find the opposite side. So again, which of the formula we need to use? It needs to include the opposite and the adjacent. The only one that does both of those things is your tan, right? So your tan is opposite over adjacent. So tan 50 is equal to x, which is the opposite, over your adjacent, which is 4. Right, so an easy way of finding the subject here is to cross multiply. So you take your denominator of one side, you multiply by the numerator of the other side, and you do the opposite for the others, right? So numerator by denominator, numerator by denominator. So the 4 will multiply by the tan 50 to get 4 tan 50. The 1 will multiply by x to get x. So x is equal to 4 tan 50. You put this into your calculator and you get 4.77 centimeters. Right, very simple. So the last part of this of the right angles is where you have to find the angle now. Right, so they gave you two sides and now you have to find the angle. So this is the angle they gave you here, x. So, and they gave you the opposite, which is 3, and they gave you the hypotenuse, which is the side opposite the right angle, which is 5. So you need to use that information to get the angle. So again, which of the formula will include opposite and hypotenuse? We know by now it's the sine. Okay, so we write sine x, which is the angle we want to find, is equal to opposite over hypotenuse, which is equal to 3 over 5. Now we can't just remove the sine from the x by dividing by sine. Sine always needs to attach to something else, right? It needs to attach to a number. So on your calculator, there's a function that does this for you. It's called sine inverse. And you typically do this by pressing the second function button on your calculator and then pressing the sine button. You will see the sine inverse on top of the sine button in a different color. So you press that color and you press sine to get sine inverse. Okay, so to find x, we simply need to sine inverse everything on the right hand side. So we sine inverse 3 over 5, and when you get this in a calculator, you will end up at 36.87 degrees, and that is your angle x. Alright, okay, so that was right angle triangles. That's almost the bulk of what we are going to do today. Now let's take a look at a non-right angle triangle. So this is just a normal triangle with no right angles in it. Now it's very important to label the triangle correctly every time. No matter what triangle they give you, I want you to label your sides according to letters and your angles according to letters as well. So we can use 3 simple letters, A, B, C. So you use capital A, capital B, and capital C for your angles. You can see them on the points here, right? And all the sides that are opposite to your angles, I want you to use the common forms of the letters. So the side opposite to capital A is common A. The side opposite to capital B is common B. And the side opposite to capital C, common C. This is very important when we are dealing with the sine rule. So the sine rule states that the side A, small a, over the sine of the angle A is equal to the side B over the sine of the angle B, which is equal to C over the sine of angle C. Okay, so the question is only going to give you information on any 2 of the following sides, right? They are not going to give you all 3 sides or all 3 angles when we are dealing with the sine rule, right? You can only use 2 at a time, right? So any combination of these will allow you to find the missing value. All right, so they could either give you information on A and B, A and C, or B and C, right? They will never give you more than 2. They will never give you all 3 sides. So let's take a look at an example of using the sine rule. So in this triangle, let's take a look at the information that they gave us. They gave us the angle at B, which is 42 degrees. They gave us the side B, which is 7.6. And they gave us side C, which is 6.5. As you can see, they did not give us anything to do with angle A or side A. What they are asking us to find is the angle at C. So therefore, using my sine rule, I will have to use B over sine B is equal to C over sine C. That's the information that they gave us. And we are trying to find the sine C. Alright, so therefore we need to make that the subject of the formula. So the first thing we do, we substitute all the information into our equation. So B is 7.6. The angle at B is 42, so sine 42. The side of C is 6.5, and then we have sine C, which we are trying to find. Again, when we are faced with 2 fractions like this, it's always easier to cross multiply, numerator by denominator, numerator by denominator. So we end up with 7.6 multiplied by sine C is equal to 6.5 multiplied by sine 42. We have the 7.6 here that we don't want, so we can divide both sides by 7.6. So we end up with sine C is equal to 6.5 sine 42 over 7.6. And again, we are trying to find an angle, so therefore we use sine inverse. So we sine inverse this whole thing, and when we put it in our calculator, we get 34.9 degrees. And that is the angle at C. And all your sine rules will look exactly the same, just like this. Sometimes you may be required to find a side instead of an angle. It does not matter, you just make that the subject of the formula. Okay? So let's take a look at the other one now. This is the cosine rule. This gives students the most trouble of all, simply because the cosine rule is a kind of large rule, right? And sometimes even with a calculator, it can get complicated if you don't break it up into parts. Okay? So the only time you will have to use the cosine rule is when the question gives you information on all three sides. Okay? So as long as they're asking you for a side and they give you two other sides, you already know you cannot use the sine rule. You have to use the cosine rule. So the cosine rule has three different forms, but it's very similar for each one. It depends on which side we are trying to find or which angle we are trying to find. Okay? So in this example, they gave us side A and side B, and they want us to find the side C. Okay? So let's take a look at the cosine rule. The three forms: a squared is equal to b squared plus c squared minus 2bc cos a. Remember, all of this is multiplied. So this is 2 multiplied by b multiplied by c multiplied by cos e. The other versions, all they do is just flip around the letters. Okay? Instead, you have the b squared is equal to a squared plus c squared, and you have the c squared is equal to a squared plus b squared, right? So you identify the side or the angle that you want to find, and you use that one instead. Alright, so in this example, we want to use C. So therefore, we actually use the third version, which is C squared in front. Alright, so we write down our formula and we start substituting as usual. So A is 7.8, so we put that there. B is 6.4, we put that there. And then we have to minus 2 multiplied by A again, so we put 7.8. Multiplied by b, which is 6.4, and finally we have to cos the angle at C, which is cos 30. We have put all the information. It still looks very complicated, so when something looks very long like that, it's always easier to break it up into some parts. Alright, so take a look at how I broke it up. You have the blue part and I have the green part. So I put the blue part into my calculator and I got 101.8. So that's 7.8 squared plus 6.4 squared. I got 101.8. And then the green part, I also put it into my calculator and I got minus 99.84. Just don't forget that we have to multiply that by cos 30. Alright? So the next step, what I did was I actually multiplied the green part by cos 30 and I got this value here, negative 86.46. Now I can take that away from the 101.8 and I got 15.34. And finally, remember, that's equal to c squared. So to find c, all we do, we take the square root of 15.54 and I end up with 3.9. Okay, so that's how we find that side. Now let's take a look at another scenario using the cosine rule where we have to find the angle now. So let's take a look at this triangle. As you can see, they gave us the three sides of the triangle. There's no reason to have to use the sine rule here, because you can't use the sine rule when they give you three sides. Alright, so they gave us three sides and they want us to find the angle. Now which one do we use? We have to use the one that includes the angle at A. Alright, so let's go back to our three forms of the cosine rule, and the only one that mentions cos A is the first one that begins with A. Alright, so we have to use the a squared is equal to b squared plus c squared minus 2bc cos A, because we are trying to find A, the angle at A, right? The other two does not have cos A, so we have to use the first one. So again, we write down our formula, and now we are going to substitute everything in the equation. Right, so this one uses a little bit more maths, but nothing really that much. So let us substitute now. So A is 4.9, B is 8.2, C is 5.7. So we include 8.2 by the B, 5.7 by the C, and then cos E. Right, we're trying to find the E. So we need to actually send everything to the other side and leave cos A alone. It's not as simple as the first one where C was already the subject of the formula. In this one, we need to actually make cos A the subject of the formula. So again, this is a very large and complicated looking thing. So let's try to break it up. In this scenario, I want us to actually work out every squared value one time. So I'm going to put 4.9 in my calculator, and I'm going to get 24.01. I'm going to put 8.2 squared in my calculator. I got 67.24. And finally, 5.7 squared will give me 32.49. So remember, I want to move all of that to the other side of the equation, the left side. So I'm going to move the 67 and the 32 to the other side. Remember, when we are moving things to the other side, we need to change the sign. So 67 becomes negative 67, 32 becomes negative 32. So I put my 24.01 minus 67.24 minus 32.49 into my calculator, and I got this value, 75.72. I'm very happy about that. So while I have simplified that now, I want to work out my green part, which is the part before the cos A. So I put that into my calculator, and I got negative 93.48, and I have to also include the cos A at the end. So to make cos A the subject of the formula now, all I have to do is divide both sides by the negative 93.48. So I did that, and I end up with cos A is equal to negative 75.72 over 93.48. And if you don't want to include the negative signs, all you have to do, remember, when two negatives either multiply or divide, they become positive. So you can actually just do this as 75.72 over 93.48. Okay, it would not make a difference. So when you're trying to find the angle, we need to take the inverse. So we say cos inverse is equal to 75.72 over 93.48. When I put this into my calculator, I got 35.9 degrees, and that will equal my x. Okay, so this is not quite the end of trigonometry. So in our next class on Thursday, we will finish that up. So that's using bearings and also angles of elevation and depression. So thank you guys for listening, and I'll see you guys in the next class.